Alright, so now let's go to subtopics 5.2, which is about alkenes. Okay, so basically, this is the full mind map on what we are going to learn about subtopic 5.2 alkenes. You might not understand it now, tapi I hope that as we go through this, I hope that this mind map will find you useful. Okay? Okay guys, basically alkenes ni dia ada general formula of CnH2n di mana n ni must be greater than or equal to 2. Okay? Lepas tu alkenes ni dia ada functional group carbon-carbon double bond, and also alkene adalah unsaturated hydrocarbon. Because kenapa? Because dia ada multiple bonds kat sini. Dia bukan single bond. Okay? Lepas tu, setiap carbon yang ada double bond tu, all of them are sp2 hybridized. Kenapa sp2 hybridized? Because dekat bond ni dia ada satu sigma bond and also satu pi bond. Alright? Lepas tu, kalau let's say alkenes ni, dia ada restricted rotation. How do you know that ada restricted rotation? Because kalau let's say dekat carbon-carbon double bond ni, okay, dia ada two different groups yang attached pada this carbon-carbon double bond, maka dia adalah restricted rotation. Okay, lepas tu kalau dia ada restricted rotation about the carbon-carbon double bond, makanya dia boleh menghasilkan cis trans isomerism. Alright. Next is cycloalkene. Cycloalkene is basically alkene yang di dalam cyclic structure. Okay, kalau let's say you ada nampak cyclic structure yang ada double bond, macam contohnya macam ni, we call it as cycloalkenes, and the general formula adalah CnH2n minus 2. Okay, the isomeric to alkynes. Okay, this general formula ni kiranya kalau let's say cycloalkenes dia boleh buat functional group isomerism with alkynes. Alkynes tu apa? Alkynes ialah carbon-carbon triple bond. Alright. For example, this is cycloalkenes with general formula C4, general formula with molecular formula C4H6. Okay. So this is how it looks like. Kalau C4 tu maksudnya kalau ada cyclic structure segi 4 lah. And then akan ada satu double bond kat situ. Since that dia isomeric, dia boleh buat functional group isomers dengan alkynes. Okay, so this is how it looks like kalau let's say alkynes yang mempunyai molecular formula of C4H6. Nak namakan alkene by using the IUPAC nomenclature. Previously, we have learned how to name an alkene by using the IUPAC nomenclature. Tapi kalau nak namakan alkene ni lebih kurang sama je macam alkene, cuma dia ada few twists. Alright? For example, kalau let's say untuk alkene, previously kita boleh just determine the parent name by looking at the longest continuous carbon chain. But since that this is alkene, okay, you need to look at the dekat your organic compound and find the parent name by selecting the longest carbon chain yang continuous that ada functional group double bond. For example, like this, okay? And also, since that dia ada functional group alkene, therefore, bila you nak namakan the parent's name, you tak boleh letak the suffix to end dengan ane, because ane adalah untuk alkene, okay? Tapi ene untuk alkene, because dia ada apa? Dia ada functional group carbon-carbon double bond. So you need to letaklah dia punya parent name ending with e and e. Okay? Lepas tu, since that dia ada functional group, kalau let's say carbon tu, carbon yang longest continuous carbon chain tu, dia ada more than 3 carbons, then you need to number your organic compound tersebut, okay, supaya kita boleh locate the double bond tersebut, okay. So for example, if you look at this organic compound, dia ada more than 3 carbon atoms, which ada 8. So therefore, you need to locate the double bond. So you need to numberkan the numberkan the carbon, the parents carbon, okay. So macam nak numberkan, you need to numberkan dia starting yang paling dekat dengan functional group double bond ni ya. For example, if you look at this, dia numberkan daripada kiri ke kanan instead of kanan ke kiri. Because kalau kanan ke kiri, okay, double bond tu, dia akan jatuh dekat carbon number 5. While if kita numberkan daripada kiri ke kanan, kita akan dapati double bond ni berada pada kedudukan carbon number 3. So, this is the closest. Therefore, the name of this organic compound yang ada double bond ni, okay, dia punya parents name dia ialah octene. Just because dia ada 8 carbon, kalau 8 carbon, oct. And then, since that dia ada double bond here, so you have to end dengan E and E. So, jadilah octene. Lepas tu, since that this organic compound, dia ada more than 3 carbon atoms, therefore you need to numberkan the carbon dekat parent ni untuk locate kedudukan double bond tu. That's why kita tahu dekat carbon number 3 ada double bond. So, letak sajalah 3 octene. Faham? Okay, next. Macam mana kalau let's say you punya alkene organic compound tu dah ada substituents? Macam mana you nak numberkan dia? Okay, previously bila kita belajar pasal alkene organic compound, since everything is single bonds, okay, tak ada langsung kewujudan functional group. Bila you nak numberkan the parent chain of your alkene yang ada substituents, you kena numberkan yang paling dekat dengan substituents. Tapi berbeza dengan alkene. Sebab alkene sekarang dia ada functional group, kehadiran functional group. So the priority will be given to the kehadiran functional group instead of the substituent. Okay. So kiranya bila you ada alkene organic compound, bila you nak numberkan dia punya parents, you have to look at the functional group of the alkene. Di mana kedudukan yang paling dekat untuk kita numberkan dia. Okay. Lepas tu the rest of it, kalau let's say substituents tu, kalau let's say dia ada kehadiran substituents, dia just follow sahaja number yang kita dah tentukan berdasarkan yang paling dekat dengan functional group carbon-carbon double bond dekat alkene organic compound tu lah. Okay, as you can see here, contohnya kita tengok yang this one first. This is the parent because parent of the organic compound tu, because dia ada the longest continuous carbon chain yang include the double bond, where we have 4 carbon atoms, kalau 4 but, and since that this is an alkene, so but E and E. Lepas tu, since that this organic compound, dia punya parent chain of this alkene ada more than 3 carbons, you kena numberkan to locate the position of the carbon-carbon double bond. In this case, kita numberkan daripada kiri ke kanan instead of kanan ke kiri, because kalau daripada kiri, carbon number 2 terus jumpa double bond. Faham? So, the parent's name will be 2-butene. Okay, 2 ni untuk siapa? 2 ni untuk kedudukan carbon-carbon double bond. Faham? Okay, next. Barulah you letak nama substituent. Substituents dia akan ikut saja, dia akan follow through saja number ni, since that carbon-carbon double bond dekat carbon number 2, dia punya starting ni, and also this CH3 falls dekat carbon number 2. So the way you want to name this substituent is going to be 2-methyl. Okay, lepas tu nak sambungkan dengan nama parent, since that this is huruf, this is angka, so letak sahaja dash kat situ. Lepas tu lekatkan saja 2-butene. Alright, so let's look at this example pula. Okay, the longest continuous carbon chain yang ada carbon-carbon double bond ni ada 6 carbon. So 6 hex, since that this is the functional group carbon-carbon double bond is going to be hexene. Okay, lepas tu kita kena numberkan this parent, just because of the carbon chain ni, dia punya longest continuous carbon chain ni ada more than 3, so we need to locate kedudukan double bond tersebut, di mana we will number the parent carbon ni daripada kiri ke kanan instead of kanan ke kiri. Because kalau kiri ke kanan, carbon number 2 dah terus jumpa double bond. Faham? Carbon number 2 terus jumpa double bond. So, nama parent dia will be 2-hexene. Okay, ni nama parent. How about substituent? Okay, as you can see here, we have two substituents yang identical, which we have dua CH3 kat sini. Okay, so kalau dua identical substituents, kita kena letak perkataan di. Okay, lepas tu barulah letak substituents yang sama tersebut, which is in this case ialah dimethyl. Alright, lepas tu since that memang ada dimethyl, okay, tapi CH3 ni berada pada kedudukan carbon number 2 dengan number 5. Macam mana you tahu number ni? Because they just follow through sahaja guidelines yang di mana kalau alkene tu you kena numberkan mengikut priority dia. Priority dia will be given to the kedudukan carbon-carbon double bond instead of the substituent. Substituent dia hanya akan follow sahaja number yang kita dah numberkan according to the kedudukan carbon-carbon double bond. In this case, we know that CH3 ni berada pada kedudukan carbon number 2 and carbon number 5. Therefore, it will be 2,5 dash dimethyl dash 2-hexene. Okay, ni nama dia yang according to the IUPAC nomenclature. Okay, yang keenam, kalau let's say your alkene organic compound ada more than one double bonds, macam mana pula? Okay, the way you want to name it is going to be diene atau triene. Tengoklah kalau let's say for example, if you look here, dekat this organic compound ada dua double bond. So, it's going to be diene. You have to endkan nama kat belakang tu dengan diene. Kalau ada tiga double bond, jadilah triene. Jangan risau, dia takkan more than 3, okay? Lepas tu, macam mana nak namakan dia? Previously, kalau let's say you see here, kalau let's say dia punya longest continuous carbon chain yang ada double bond ni, yang ada 4 carbon, kita namakan dia butene kan. But once dia ada more than one double bond, okay, nama dia diene. You kena letak diene kat belakang. Tapi instead of, memang ada 4 carbon, instead of jadi butene, jadi buta. You kena letak huruf A kat situ ya. Butadiene. Okay. And then you kena numberkan juga kedudukan double bond tersebut. For example, kalau I numberkan kiri ke kanan ke kiri ke sama sahaja. Okay, is going to be 1,3-butadiene. Okay, kat sini kalau you tak rasa tak tahu macam mana, you tengoklah kat kedudukan carbon number 1 terus jumpa double bond. And then kedudukan carbon number 3 terus jumpa double bond. That's why it is 1,3-butadiene. How about this one? Okay, for this one, okay, dia ada 3 double bond in one organic compound ni. So, the way you want to name it at the end, instead of dia jadi heptene sebab ada 7 carbon longest ni kan, you have to change the name dengan letak A dulu kat depan, dekat ni. You kena letak A dulu. Sekejap ya. Letak A dulu. Lepas tu, letaklah nama last dia, triene. Okay. Lepas tu, you have to bagi tahulah kedudukan double bond tu dekat carbon number berapa. In this case, kedudukan carbon number 1, number 3 and number 5. Okay, so that's why dia punya nama dia ialah 1,3,5-heptatriene. Okay. Next, macam mana nak namakan cycloalkene yang ada substituent? Jangan risau, kita still have to prioritize kedudukan carbon-carbon double bond. Since that, for example, kalau let's say you ada cyclic structure yang hanya ada satu sahaja double bond, okay, therefore the carbon atoms akan terus auto jadi carbon number, either carbon-carbon double bond tu either carbon number 1 atau carbon number 2. And also you have to bagi number tu di dalam direction yang akan buatkan substituents tu dapat the lowest number. Okay, for example, if you look here, memanglah carbon-carbon double bond ni kat sini. Okay, memanglah carbon, kita prioritizekan the position of carbon-carbon double bond. Kita kena terus letak nombor 1 kan. Carbon number 1 kan. Okay, so kat sini, dia letak carbon number 1 ni dekat sini. Carbon number 2 ni kat sini. Sebab kenapa? Sebab carbon number 1 ni, besides kita dah prioritize kedudukan carbon-carbon double bond, also ada substituents. Okay, instead of you numberkan carbon number 1 kat sini, 2 sini, 3, 4, 5 macam ni. Okay, this is wrong. Kalau kita direction macam ni, this is wrong. Because why? Because carbon number 2 baru jumpa substituents. We cannot do that. So that's why kita letak carbon number 1 dekat sini. Okay, 2, 3, 4, 5. So nanti dapatlah carbon number 1 ni functional group carbon double bond and also substituents methyl. So since that this cyclic structure ada 5 carbon atoms, okay, so nama parent dia will be pentene, cyclopentene tau, because this is a cyclic structure, so it's going to be cyclopentene. Okay, and then tak perlu pun number kan kedudukan carbon-carbon double bond, because kita dah tahu kalau let's say in a cyclic structure, kita terus prioritizekan carbon number 1 tu adalah dekat carbon-carbon double bond. So we don't need to letak 1 methyl 1 cyclopentene. Okay, so it's going to be 1 methyl cyclopentene sahaja. Okay, same goes to this cyclic structure. As you can see here, instead of I buat carbon yang pertama dekat this carbon, okay, 2, 3, 4, I letak carbon number 1 dekat sini. Because why? Because nanti dekat carbon number 3 terus jumpa substituents methyl. Okay, and then since that this is cyclic structure yang ada 6 carbon atoms, therefore nama parent for this cyclic structure will be cyclohexene. Okay, cyclohexene instead of 1 cyclohexene, dia terus cyclohexene because memang dah sah-sah kalau let's say in cyclic structure yang ada 1 sahaja double bond, dia memang terus jatuhlah carbon number 1 tu dekat the beginning of the carbon double bond. Okay, cumanya we can see here dekat kedudukan carbon number 3 and 5 we have 2 identical substituents which is methyl. So kita bolehlah kumpulkan nama dia jadi dimethyl. Okay, so dia nama penuh dia will be 3,5-dimethyl cyclohexene. Okay, so what if alkene ni dia jadi substituents? Kiranya dia tak jadi parents lah. Previously kalau kita belajar any alkene group, okay, yang jadi alkene yang jadi substituents, kita kena letak YL kat belakang kan. Okay, so you must be thinking, okay, nak namakan alkene bila alkene ni dia dah tak jadi parent, jadi substituents, we have to put YL kat belakang jadi alkenyl. Okay, so basically kalau bila alkene ni dia jadi substituent, ada 2 nama famous dia yang you should know of, such as vinyl dengan allyl. Dia jadi vinyl group dengan allyl group. Apa tu? Okay, for example, if you look at these 2 organic compounds, okay, kita boleh nampak kat sini alkene ni dia jadi substituent. Sebab kenapa? Kat sini we can see that the parent's name here ialah benzoic acid. So jadinya benzoic acid dia lagi powerful daripada alkene, so that's why lah dia jadi parent. Okay, so bila dia jadi parent, alkene ni dia akan jadi substituent. So instead of you jadikan nama dia alkenyl, so you have to look at sama ada dia vinyl group atau allyl group. Kalau let's say alkene jatuh bila jadi substituents, nama dia vinyl, it is because dia punya structure dia lebih kurang macam ni. This is the parent, okay. So if you look here, this is the parent. Okay, so this is the parent. And then bila dia melekat dengan alkene CH double bond CH2, okay, bentuk macam ni, kita namakan dia sebagai vinyl. Okay. Lepas tu, kenapa dia jatuh pada kedudukan carbon number 3 is because kat sini COOH ni dia jadi priority untuk kita numberkan dia kedudukan carbon number 1. Therefore, carbon number 3 ni ada substituents alkene di mana bentuk dia adalah bentuk vinyl group. So that's why it's going to be 3-vinyl benzoic acid. How about this one? This one pun dia punya parent dia ialah benzoic acid. Okay. Tapi kat sini kita boleh lihat alkene jadi substituents. Substituents jenis apa? Jenis allyl. Di mana dia macam mana bentuk dia jadi allyl tu is when parent tu dia lekat dengan carbon CH2 terus, okay? CH2 ni, CH2, CH double bond CH2, okay? So kat sini bila kita nak numberkan dia punya parent tu, is going to be carbon number 1, carbon number 2 kat sini with substituents alkene, allyl, okay? So jadilah 2-allyl benzoic acid. Okay, next. Macam mana you nak namakan bila dia ada macam contohnya lah cis trans isomers macam ni. As I told you before, kalau let's say dekat carbon-carbon double bond ni, benda yang sama dekat carbon belah kanan dan kiri ni berada pada position yang sama, sama ada di bawah atau di atas. We call it as cis. Okay. And then kalau trans pula dia alternate, satu dekat bawah, satu dekat atas, trans. Okay, tapi macam mana nak namakan dia? Don't worry about it. In this case kita sebabkan dia ada dua sahaja, carbon atom, so nama parent dia will be ethene. Okay. Lepas tu macam mana pula kita nak numberkan this carbon? Supposedly kalau let's say if it is a straight chain alkene, kita tak perlu numberkan the carbon kalau let's say dia ada less than 3 carbon atoms, tapi in this case we need to number it down just because dia ada substituent Cl kat sini. Okay, Cl ialah functional group for halogen, so that's why kita kena numberkan kedudukan halogen tersebut. In this case, tak kisahlah kanan ke kiri ke kanan, sama saja. Di mana kat sini dia punya parents name ialah ethene. Tapi kat carbon number 1 dengan 2 ni ada 2 chlorine atom. 2 chlorine atoms. So bila dia jadi substituents, jadi chloro. Since ada 2 identical substituents, so it's going to be dichloro. Okay, so nama penuh dia ialah 1,2-dichloroethene. Tapi tengoklah kalau macam ni cis rupanya. Kalau rupa macam ni pula trans. So that's why the trans 1,2-dichloroethene. Okay, so to test your understandings, you can try to give all of these organic compounds alkenes according to the IUPAC nomenclature. Okay, next is about the physical properties of alkene. Okay, the only physical properties of alkene that you need to learn is about the boiling point of alkene. Okay, boiling point ni, faktor yang paling mempengaruhi boiling point of organic compound ni apa? Is the type of intermolecular forces of the organic compound tersebut. Okay, kalau alkene dia hanya ada carbon-carbon double bond, isn't it? So dia ada carbon and also hydrogen. Okay, just like alkene, dia ada carbon dengan hydrogen. Therefore, the type of intermolecular forces untuk alkene adalah apa? Adalah van der Waals forces. Okay, so since that dia ada type of intermolecular forces, van der Waals forces, so you have to recall what is the factor yang mempengaruhi kekuatan van der Waals force. Ada 3 sahaja, which we have learned previously, and also dekat alkene and also dekat semester 1, di mana the strength of van der Waals forces dia akan influence by the molecular size ataupun molar mass lah, molecular size. Kiranya lagi banyak, in this case lah, kalau alkene lagi banyak carbon atoms, lagi berat lah dia punya molekul tersebut kan. Molar mass dia lagi besar, therefore lagi kuatlah dia punya van der Waals forces. Next ialah about the molecular polarity. Okay, molecular polarity ni contohnya kalau let's say dekat your alkene ataupun alkane tu dia ada something yang polar, macam contohnya yang ni C double bond CH2. What if I gantikan H ni dengan F, makanya dia akan menyebabkan um, sesebuah organic compound tersebut dia ada polarity dekat situ. Okay, sebab F is more electronegative than C. And lastly is about the molecular shape. Okay, molecular shape pula macam mana? Kalau molecular shape dia lagi prefer straight chain daripada branch. Okay, sebab kalau branch dia lagi compact. So bila lagi compact dia lagi rendahlah dia punya van der Waals forces dia. So dia lagi prefer straight chain. And also kalau tambahan kat sini, because we have learned about cyclic structure, so cyclic structure pun dia akan lagi kuatkan the van der Waals forces. So once the van der Waals forces tu dia kuat, maknanya kita susah nak break the bond, therefore the boiling point will be higher. So you have to look at these factors lah. Kita dah belajar ni time dekat sem 1, okay? So this is just for you to recall. So you can look at this explanation here. Dia bagi tahu kat sini the boiling points of alkenes akan increase smoothly with the molecular weight. That's what I told you here. Okay. Lepas tu kalau branch punya alkene akan lead to the lower boiling point. Sebab kenapa? Kalau branch alkene dia lagi compact. Okay. Yang specialnya untuk boiling point alkene ni is about cis trans punya isomerism. Okay. Kalau let's say alkene tu dia ada cis isomers, therefore dia akan ada higher boiling points compared to trans isomers. Okay. So kalau let's say ke alkene dia ada pertambahan cis versus dengan trans isomers, where we know that kalau cis isomers dia punya boiling point lagi tinggi berbanding trans isomers. Okay, because cis isomers dia ada greater dipole moment yang akan menyebabkan van der Waals forces ni bertambah kuat. Okay, so point dia kat sini, kalau boiling point sesebuah organic molecule, kalau alkene ni, kita tengah cakap pasal alkene ni kan, kalau boiling point of alkene tu tinggi, it's because of van der Waals forces dia tu kuat. Kalau apa-apa je factor in here yang I already discuss with you yang menyebabkan van der Waals forces ni kuat, therefore susah nak break the bond, therefore boiling point dia tinggi. Okay, itu saja.